splices in aircraft skin, I prefer to use this method if I have no other guidance material. It'll give you quite a few rivets, but you can be sure that there's more than enough rivets in order to hold the structure together. This is kind of interesting too. On World War II aircraft, some warbirds, there was a repair technique where they used resistance welding in the original construction, where the spot weld is broken. And what they allowed you to do was replace the broken spot weld with a rivet. It's acceptable provided that repair information is specified by the airframe manufacturer. But over the years, people have gotten kind of complacent, and the FAA says if there's no information that says that you can do this, you can't. So unless it's specifically talked about in the structural repair manual, you can't do it. But what they've done is they've drilled out an old spot weld, and they replaced it with a countersunk rivet with a washer on top of it in order to kind of secure it back into the structure. So they use a spacer kind of as a washer and a countersunk rivet to do it. But this repair still exists in some military aircraft. This is from a NAVAIR repair manual. They still use a lot of the old military aircraft still use spot welds in the construction. By the way, that's an interesting way of constructing aircraft. When you spot weld steel, it's a lot different than spot welding aluminum. It requires a different type of welding technique. The grain structure of aluminum is enlarged when you weld it by resistance welding. They didn't know that in World War II. They found out later that it can induce cracks in the aluminum when you spot weld it. But again, they spot welded a lot of warbirds because it was a quick and efficient method of getting your aircraft out to support the war effort. But they didn't find out much later that that method of assembly, although it's expedient and fast, it isn't necessarily the best method. So that's what I can tell you. Backside of FAA Form 337, this is Block 8, where you're going to have your patch illustrated and also the descriptor for it. And put up a picture. Example of what would be required for a logbook entry for a repair. So here's what the information they give you out of Part 43.9. You're going to have a date. You're going to have a statement of the work accomplished. You're going to have a signature. And you're going to have a certificate number. Those four elements are required for all repairs in a logbook. So you'll notice, just like I told you for the other examples, very brief information. If a person is very curious about the repair, where will they look? Is that 337? Okay, that's where they're going to look. I didn't list out how many rivets I used, or the shape of the patch. I might have had a location, and I might have briefly mentioned where the repair information came from, but if a person gets curious, they're going to look at that 337 to find the data for the repair. I'll talk to you about this. Years ago, I did a repair of that twin Comanche. This is the 337. I blocked out owner's information for it, but I wanted to save this as a sample. I worked with another mechanic in repairing this aircraft. There's an interesting story that went with this airplane. The airplane was involved in a gear-up landing, and the landing was so severe it damaged or eroded a lot of the aircraft's skin. It all started with a bad battery ground as part of the electrical system. What happened was the aircraft owner was in flight going to, it was Montgomery Field. Okay. So anyway, it's at night, and he attempts to lower the gear down. It's an electric gear on that aircraft, and gear won't come down. And the reason being is because the electrical system, there wasn't enough power as a result of the bad ground on the battery. So the generator or alternator couldn't charge the battery, so it couldn't make the electric motor work for the gear. Not only that, the electrical failure also caused the indicating system not to work either. So when the pilot attempted to do an emergency extension of the gear by using the over-center lever, well, there was no indication for a green light for gear down and lock because no electricity. All of this, of course, occurring at night. So the aircraft settled down on what the aircraft owner thought was locked gear, but it wasn't. The the main gear was not locked in the down position, and the nose gear was not locked, so the aircraft went in on one side. It damaged both of the propellers, so sudden stoppage in both of the aircraft engines. The propellers were Q-tipped, and it skidded down the runway. All of the aircraft skin was eroded from the rudder pedals after the tail post. So a lot of repair work had to be done. So in addition to the engine, so a lot of damage. This is how we addressed the 337 from on the backside. Certain areas had to have reinforcements. Certain areas had to have additional splices made for a new skin that had to be done. Other parts had to be fabricated. And the way that we kind of laid it out, I thought was kind of good because everything that had to be done kind of separately had its own little section of what had to be done. So where we had to add, or at least it says, repair the following cracked bulkheads and brackets by adding 2024 LCAP reinforcements. All of the cracked bulkhead assemblies that had to be repaired by reinforcements were located by part number and the station that they were at. All of the new factory parts that had to be replaced because we couldn't repair them, all of those parts are listed separately. All of those sheets of the aircraft skin that had to be spliced by new skins coming in, those areas were specified as well. Any of the skins or reinforcements, or at least any parts that had to be fabricated, they're listed separately as well. And this is, I think, it was a continuation of some of the skin structure that had to be spliced or had to be reinforced was listed in another area. None of this involved a hidden repair because all of the repair could be examined after it was been done. So there, of course, you're not going to find an IA's inspection for pre-closure because it's not required. All is invisible. So, but this is what was required on the aircraft, and this was a long process in doing it. I learned some valuable tips that I'll share with you too. Never throw away anything. The old aircraft skin that had been eroded, even though you couldn't reuse that skin, it provided locations for rivets. So all the rigid rivet location spacing was the code for it was in that old skin. So that told us a lot. So we just laid out the new skin using the existing patterns that were on the old original skin. In some cases, we even used it as an indication of how much material was required to make a part, and you could kind of trim around the existing part with the new skin in order to fabricate it. So again, I learned a professional helped me with this. So this was a huge job. But anyway, that's how we kind of dealt with it. If you're ever in doubt as to what's considered to be a major repair for the airframe, this is where you will look. You're going to look in FAR Part 43 Appendix A, and it'll tell you if a specific operation is considered to be a major repair or a major alteration. So, for example, let's take a look at, I think I got this mapped out by squares. Part 43. All of these are considered to be major alterations in this area. Major repairs for the airframe are down here. So, let's see what it says for major repairs. Major repairs. Airframe major repairs. Repairs of the following parts of the airframe. Repairs of the following types involving the strengthening, reinforcing, splicing, and manufacturing of primary structural members or the replacement. When replacement is by fabrication such as riveting or welding, are airframe major repairs. So what this tells you is pretty much everything. If you're working on primary structural components where there's fabrication involved, where the assembly is going to involve rivets, that pretty much defines it as being a major repair. Box beam spars of wings, monocoque or semi-monocoque wings or control surfaces, wing stringers, cord members, spars, spar flanges, truss-type beams. All of these are pretty much structural component parts of the aircraft. Wing and tail brace struts, repair of damaged areas of metal or plywood, stress covering exceeding 6 inches in any direction. So again, there's multiple things here. There's splicing of any sheet metal. That's considered to be a major repair. You've spliced in any location. So, okay. When in doubt, let's say, for example, you've got what you consider to be a questionable thing that you might believe is a major repair. Don't hesitate to call the local official and ask. They'll help you. when in doubt, it's probably best to execute FA Form 337 than not. So at least you've covered yourself. If the FA doesn't believe it to be a major repair, they'll throw it away. But at least you documented to the best of your ability what you believe to be a major repair. So, but call in advance. We've got a very good relationship with the local FITSO here. They're more than happy to kind of help you if you want. It's not like other places, and I've seen some horror stories working with some FA reps out of other areas, but locally they're actually very good. Anyway, major alterations are covered in a different section, and that's what we've got. It's now what time is it? Okay, why don't we take a break for a half hour and I'll see you back.